Yeah, right. Yes. Yesterday we stopped at the 4n plus 2 electrons involved electrocyclic reactions, or reversely I have given electrocyclic reactions involved 4n plus 2 electrons.
Yes,
In that
yes,
Kahn electrocyclic reactions, the ring closure reaction and the ring opening reaction. In these two, the transition states we are already discussed. I have given the practice for the diselectrocyclizations. Okay, the same observation you have found. Do you found the same observation?
no, no, it's
Is it appearing clearly appearing? Is my screen is visible to you all clearly?
sir.
Can you able to
Yes,
recognize?
yes, sir, it is visible.
Right, right. Thank you. Right. Yeah. In this, you can see that yesterday I have given this. This is as for your practice. This electrocyclization. In the ring closure reaction, this is the transition state involved. In the diselectrocyclization, one at the first end it is undergoing the clockwise. At the first end it is undergoing clockwise. Right. This is the clockwise rotation at this end. Right. At the second end, it is undergoing excuse me, anti-clockwise rotation. Then, on rotation of clockwise rotation of the first end, this is the first end. At this end, it is undergoing clockwise rotation. Therefore, above lobe, the topmost lobe is moving to inside. At the second end, the also topmost lobe is moving to inside. The bottommost lobes, both sides are rotate on rotation. It moves to outside the sigma formation. Now it leads to the formation of a transition state. This is the transition state actually. This is the transition state. In this transition state, there is no nodes, zero nodes, or if you sometimes it may gives a odd number of nodes, sorry, even number of nodes. Then the pi system is the transition state is involving 6 pi electrons or 4 and 5 plus 2 electrons in order in the transition state. The transition state becomes Huckel aromatic transition state. Once the transition state is involving zero number of nodes with 4 and 5 electrons, that transition state is Huckel transition state. And once it is Huckel transition state, that becomes aromatic whenever it is having the 4 and 5 plus 2 electrons with even number. Then it is thermally allowed, photochemically forbidden. In the ring opening reactions, this is the closed system. A base set is taken. It is undergoing, this is the anti-clockwise at the second end. At the first end, it is undergoing clockwise. Then it leads to the formation of this transition state. You look into it, look here. This, whatever this one, outside lobe is moving above, and on rotation it is also anti-clockwise at the second end. It is moving to above the sigma 1, right? Then it leads to formation of two nodes here. One node is here and another node is here. Then this is also having 0 or 2 or even number of nodes. Then the number of electrons involved in this is 4 and 5 plus 2 electrons or 6 pi electrons. This is also becomes Huckel transition state. Then what is our conclusion from this? What is our conclusion? 4 and 5 electrons, 4 and 5 plus 2 electrons or 6 electrons involved transition state undergoing or diselectrocyclization involving the transition state through the formation of Huckel aromatic transition state. Hence, the reaction allowed under thermal condition, and forbidden under photochemical condition. Right. Now, based on in the yesterday's work and this example, based on this example, the sum up into a table. All the results are sum up into a table. The selection rules for electrocyclic. This table is called as selection rules for electrocyclic reactions by the PMO method. How this table is constructed? The number of electrons in the transition state. That means whatever the type of electrocyclic reaction it is. Okay, the electrocyclic reaction involving 4n electrons and it is undergoing con and dis stereochemical modes and involving the transition state is maybe odd number of nodes or odd number of nodes and sometimes it is involving zero or even number of nodes. Based on that, we are classifying the transition state. Based on the transition state, we are classifying the reaction whether it is allowed under that condition or forbidden under that condition. Once first you take the 4 and 5 electron system or 4n electron system, which is undergoing the con electrocyclization. It is undergoing odd electron transition state. Once it becomes the odd electron transition state and it is having 4 and 5 electrons, then it becomes Mobius aromatic transition state. The transition state becomes Mobius aromatic transition state. Once it becomes aromatic transition state, that transition state is going through the transition state is broken up or cyclized to form the desired product under thermal condition. Therefore, the reaction is allowed under thermal condition and forbidden under photochemical condition. Next, second one, 4 and 5 electrons diselectrocyclization. If the 4 and 5 electrons are involved in the electrocyclic reactions and that is undergoing the stereochemistry is disrotatory of the overlapping of the two terminus of the 5 system, that is involving zero or even number of nodes. Once it becomes zero number or even number of nodes in the transition state, the transition state becomes Huckel transition state, but it is involving 4 and 5 electrons or 4n electrons. Therefore, that Huckel transition state becomes Huckel anti-aromatic because it is not having 6 pi electrons or 4 and 5 plus 2 electrons. Therefore, it becomes Huckel anti-aromatic system. Once it becomes the transition state becomes anti-aromatic, then the reaction is allowed under photochemical. The reaction is allowed under photochemical. Right. The reaction is allowed under photochemical and it is forbidden under thermal condition. Next, this is the first type. Electrocyclic reactions are involving 4 and 5 electrons under con rotation on dis rotation, two stereochemical modes. In the each stereochemical mode is different from the others. Con electrocyclic reaction is allowed under thermal reaction. That means con electrocyclization takes place under thermal condition only. Diselectrocyclization takes place under photochemical condition only. Next, 4 and 5 plus 2 electrons. This is the previous example, what we seen here. 4 and 5 plus 2 electrons. In this system, 4 and 5 plus 2 electrons, if it is undergoing con electrocyclization, it is involving odd number of nodes. Odd number of nodes. Once it becomes odd number of nodes, the transition state becomes Mobius, and the number of electrons involved in this is 4 and 5 plus 2 electrons. Then the transition state is Mobius anti-aromatic transition state. Once it becomes anti-aromatic, the reaction is proceeds under the photochemical condition and forbidden or restricted under thermal condition. Therefore, the con-rotatory electrocyclic reaction with 4 and 5 plus 2 electrons is observed under the photochemical condition but not in thermal condition. Next, in the last example, whatever we have discussed here, that is sum up here. The electrocyclic reaction is involving 4 and 5 plus 2 electrons in the disrotatory stereochemistry, and that is involving zero or even number of nodes. Then the transition state becomes Huckel aromatic transition state. Therefore, once it becomes aromatic transition state, then the reaction is proceed under thermal condition, but not allowed in photochemical condition. Therefore, allowed under thermal condition, forbidden in photochemical condition. Allowed under thermal condition and forbidden in photochemical condition. Okay, this is about we have discussed yesterday class. Right now, Analysis of cycloaddition reactions by the PMO method. Okay, perturbational molecular orbital theory or perturbational molecular orbital method is applied to the cycloaddition reaction. Then, what is cycloaddition? We have already discussed during the classification of pericyclic reactions. What are the cycloaddition
Superfraction.
reactions involved? I think all of them are joined. Those who are attended to the class, all of them are joined. Okay, 6 members. Okay, thank you.
Sir, 11 participants are there.
Yes, yes.
Sir, can you hear, sir?
Yes.
In previous, sir, when if you are considering n is equal to 1, like 4 pi e electrons, sir. When n will be 1, sir, that time thermal and photo reaction will take place, sir. Only in case of n is equal to.
That condition is explained by the theory. Just only అంతే. మనం మీరు ఏదైతే అనుకుంటున్నారో just have you seen the screen, my screen?
Yes, sir. Yes.
Okay, I'm missing here. Just a minute. My screen. Okay, what you are asking, please tell me.
Sir, in case of 4n means 4 pi electron is there, na? That case, if n is equal to 1, sir, and if it is contrary reaction, first one, sir, then
Yes, where n is equal to 1.
Yes, sir.
That is
Here,
involving 4 electrons. The 4 electrons electrocyclic reaction.
if n is
If
equal
it
to
is
1,
undergoing,
then
if you want to conduct the reaction under Kahn rotation reaction, you need to apply the thermal condition only. If you apply the photochemical condition, that is undergoing dyscyclization.
yeah.
That's
But
it.
when n becomes 0, sir, that time it won't be possible, na?
Yeah. Yesterday we are discussing the same example. N is equal to 0. How many electrons? 4 electrons. One
Yes,
comes
sir.
to the butadiene, where N is equal to 0.
Yes, sir.
We are
And in
discussing the
similar,
same example. Here we are already discussed the same. This one is the system is the where n is equal to 1. N is equal to 1. What is
yes,
the
sir.
rule? 4n 5 electrons.
Yes, sir.
How many electrons are there in that?
1. 4 electrons.
4 electrons. The 4 electrons you can see here.
Yes.
2 5 electrons from here. 2 5 electrons. And
Yes, sir.
2 5 electrons from here. Total 4 5 electrons. Whereas n is equal to 1. Where n is equal to 0, you are asking.
Yes, sir.
Where n is equal to 0, there is no existence of a conjugated pi system. Na?
Yes, sir.
If
Yes.
there is no existing pi system, it is no scope to pericyclic reaction there.
Yes, sir. Yes, sir.
Right. Now coming to cycloaddition reaction.
Yes.
Analysis of cycloaddition reaction by PMO method or PMO theory. What is cycloaddition? A conjugate addition of two pi systems. Two pi system maybe it starts from the one double bond containing compound or more than one number of double bonds containing compounds are undergoing conjugate addition that leads to the formation of cyclic product. Here, two ethylene molecules are undergoing cycloaddition either in the thermal or photochemical condition that leads to the formation of cyclobutane. Cyclobutane is the product. Now, four stereochemical modes are possible. We have already seen that. How many stereochemical modes are possible in that 2 plus 2 cycloaddition reaction? How many stereochemical modes are possible?
4
Here,
types.
given four stereochemical modes are possible. 1 and 2, 3, 4. What are the four? Supra addition. 5 to S plus 5 to S cycle addition. Supra addition. 5 to S plus 5 to S cycle addition. Supra Andra addition. 5 to A plus 5 to S cycle addition. Andra Supra addition. 5 to A plus 5 to A cycle addition. Andra addition. Right. Now, first one, if you're coming to the first one, what we need to consider for understanding or for applying the PMO method? Only we need to consider the transition state.
Yes.
What is the transition state involved? The pericyclic involving substrate molecular orbital should be in the base set, or the lower energy molecular orbital set is considered for predicting the reaction conditions. Here, 2 pi systems are undergoing cycle addition, double bond and double bond, 2 pi electron system. This is the 2 pi electron system, right? Now
Sir,
it is in the molecular orbital. This is the pi molecular orbital. This is pi molecular orbital
so
of the one pi system, or one olefin and the second pi molecular orbital. These are undergoing cycloaddition. Okay, you keep the 1 point is standard interaction. You keep the 1 point is standard interaction wherever it may be. Okay, here it is involving
nodes.
one node and a supra mode of addition. With respect to the first pi system, the same side lobes are involving in the interaction with the second pi system. This lobe is already involving in the overlapping with this lobe, and the next interaction between the second lobe of the first pi system and the bottommost lobe is involving the interaction. In the second pi system, the topmost lobe that is involving in the overlapping. Now, this is the interaction. This interaction is also lead one node. Therefore, it is having two nodes. These two are having two
Two.
nodes. Two nodes. Now, here, come to here. Another alternative. If you draw like this, the positive phase is shown in the bottom, negative phase is shown is above the plane. Now, and the another olefin or ethylene, the positive phase is shown above, the negative phase shown is below. The interaction between these two. This you maintain the standard interaction at one place, and the second interaction you show that like according to the stereochemistry applied. Supra mode of addition. With respect to the first pi system, these two lobes are involving in the overlapping, and with respect to second pi system, these two lobes are involving in the pi system. The first interaction is like this. This is the first interaction, and the next interaction is like this. Now it leads to
There is no nodes.
zero nodes. Zero
Zero nodes.
nodes. We call it as zero nodes. Then those two transition states may be involved in the 2+2 cycloaddition reaction. That is pi to s plus pi to s supra mode of addition reaction. Now this transition state, zero or even number of nodes are involved in the transition state. It consisting of 4 pi electrons or 4 and 5 electrons are involved. Therefore, the reaction involves Huckel
Huckel
anti-aromatic.
Okay.
Because the transition state is involving zero or even
Zero or
number.
even nodes.
Now, the transition state is belongs to Huckel transition state.
Okay.
Then it is 4 and 5 electrons or 4 pi electrons. That indicates that Huckel, if it is having
Aromatic.
4 pi electrons in a pi system, that is treated as anti-aromatic. That is the
Anti-aromatic.
reason Huckel anti-aromatic transition state. Once it becomes anti-aromatic transition state, the reaction is
Photochemically allowed.
chemically allowed, thermally
And
forbidden.
thermally not
Yes,
forbidden.
thermally forbidden. Right. This is the conclusion. Phi to S plus phi to S cycloaddition proceeds through the formation of Huckel anti-aromatic transition state. Hence, the reaction is allowed under photochemical condition and forbidden under thermal condition. Do you? I need to wait for copying this.
Yes, sir. Yes.
Yes, you can. You carry. Do I move to above also? Yes. You ask me, I will scroll it.
సార్ ఫస్ట్ నుంచి ఇదేనా సార్ ఇది
PMO ఇదేనండి ఫస్ట్
ఒక్క నిమిషం
ఫర్ ది cycle additions. This is the selection rule. Yesterday we are already discussed that all the results are summarized in the table. The table is called selection rule for electrocyclization by PMO.
సార్ ఇది ఉంచండి
also-
సార్ ఒకసారి
Yeah, you carry it.
Not G. Matrix. సార్ స్క్రోల్ చేస్తారా సార్?
Yeah, okay.
సార్ ఏ అంటే ఏంటి సార్? పై స్క్వేర్ ఎస్ పై స్క్వేర్ ఏ.
అమ్మా
పై స్క్వేర్ ఏ అంటే సార్ ఇది
ఏంట్రా ఇక్కడ రాశాను కదా, 5 to a, don't square, don't call
5
it
to
square. 5 to
ఓకే
s plus 5 to s, cycle addition. This is called 5 to అంటే 2 supra plus supra supra cycle addition. 5 to s, 5 to a, supra antra addition. 5 to a, 5 to s, supra and antra supra addition. 5 to a plus 5 to a, antra antra addition. 4
ఓకే
stereochemical modes. For any cycle addition which is involving 2 pi systems, it follows 4 stereochemical modes. In that
ఒక్క
first
నిమిషం
stereochemical mode, this is the transition state.
సార్. ఒక్కసారి కిందకి స్క్రోల్ చేస్తారా సార్? సుప్రా సుప్రా
So,
సుప్రా
supra supra, supra andra, andra supra,
అంట్రా.
andra andra. Yes. 4 possible combinations.
ఓకే సార్. ఓకే సార్. నెక్స్ట్
Okay, now you can copy this.
ఇది రాసుకున్నాను సార్. పైకి స్క్రోల్
Okay, great. You write the conclusion.
చెప్పండి.
Over?
ఓకే సార్.
Okay, second type of stereochemical mode, the pericyclic reaction involving pi2s plus pi2a cycloaddition, that is supra-andra addition.
Oh,
Now consider this time. This is the transition state. In this transition state, first pi system, you maintain this interaction is standard interaction, right? And the next second interaction between with respect to the first pi system, supra. Supra means the both interactions lobe should be the same side. In the first pi system, these two lobes are participating in the interactions. In the second pi system, with respect to the second pi system, this is antra. Antra means the interacting lobes should be in opposite phases. Therefore, at the first interaction, this will be participating, and the second interaction, this will be participating. Now, the interaction between the two pi systems like this. Now, it leads to the
one node.
one node. Therefore, the transition state involving one node or odd number of nodes, 4 pi electrons or 4 and 5 electrons. Therefore, the transition state becomes, once it becomes odd number, the transition state is Mobius, and the number of electrons involved, 4 and 5 electrons. Therefore, it becomes Mobius aromatic transition state with respect to those two terms. Now, once it becomes aromatic transition state, phi 2s plus phi 2s cycle addition is proceeds through the formation of Mobius aromatic transition state. Hence, the reaction is allowed under thermal condition and forbidden under photochemical condition. Yes. Copy it.
Okay.
Let me know once you complete.
Completed, sir.
Okay, right. Next, in the third kind of stereochemical mode. In the third stereochemical mode, you see that. So the same kind of pi systems which are involving first one with respect to the first pi system, it is Andra. With respect to second pi system is Supra. Now in this one is the first pi system. With respect to this Andra, opposite lobes are involving in the interaction with the second pi system. Therefore, it is you are maintaining that this is the standard interaction. Therefore, there is no node here. In the second interaction, the second first pi system, opposite lobes are involving in the interaction. Therefore, this lobe is participating in the interaction. Now it is interacting with the second pi system. That is, with respect to the second pi system, is supra. The both lobes in the second pi system interacting with the other system is on the same side. Therefore, the interaction is like this. Now it leads to again one node. Now this is already have shown in the orthogonal approach during the discussion of the stereochemistry of the cycle addition reactions. This I think you know that already I have explained in the class orthogonal approach. This is the orthogonal approach. In that, this is the second pi system. This is the first pi system. You treat it as this is the first pi system, this is the second pi system. With respect to the first pi system, opposite lobes are participating. We are maintaining the standard interaction. This is the first interaction from the first pi system. This is the second interaction from the first pi system. Next,
Okay.
second pi system. This is once you view the molecule, we view the molecular orbital from this orientation, not to the perpendicular orientation, not like this. You are viewing the molecule or molecular orbital in this direction. You can see only one lobe. The rear lobe is not appearing. Okay. Now these two are arranged in the perpendicular manner. Now the second interaction is like this. This second interaction leads to the formation of again node. Therefore, the conclusion is same. The transition state is involving one or odd number of nodes with 4 and 5 electrons or 4 and 5 Therefore, the transition state becomes Mobius due to the one number of node or even number of odd number of nodes, and it is having 4 and 5 electrons. Therefore, it is aromatic. The transition state is Mobius aromatic transition state. Now, the conclusion is thermally allowed, photochemically forbidden. Yes, Power.
Sir,
Let me know once you complete.
Completed, sir.
Okay, right. Next is fourth stereochemical mode. There is antra mode of addition. Antra cycle addition. Now the first pi system, it is antra. With respect to second pi system is antra. Okay, in the, both the pi systems, opposite phase lobes are involved in the interactions. If you maintain the standard interaction is like this, there is no node here. In the second interaction, the opposite lobes are involving in the interaction. The interactions are between these two lobes. Now there is no node generation. Similarly, this can also be explained in the orthogonal approach. Orthogonal approach. In the orthogonal approach, you can look into this. This is the first pi system. This is the second pi system. This is the second pi system. This is the first pi system. In the both the pi systems, the interacting with the nearest lobes. These two lobes are interacting each other. These two lobes are interacting each other. Now these two leads to zero nodes,
Zero.
and also you can observe that in the both the pi systems, opposite lobes are involving in the interactions. Therefore, it is the transition state is involving zero or even number of nodes with the 4 and 5 electrons or 4 5 electrons. Then it becomes Huckel transition
Anti-aromatic.
state. With respect to the number of electrons, it is Huckel anti-aromatic transition state. Once it becomes Huckel anti-aromatic, this is the photochemical allowed and thermally forbidden reaction.
Okay, sir.
Right. Now this is about the 2525 cycle additions with the analysis by PMO method. Right. Now coming to the cycle addition is involving 4 5 4 plus 5 2 cycle addition. 5 4 plus 5 2 cycle addition. That means it is involving one of the 5 system with 4 5 electrons and another 5 system with 2 5 electrons. That is 1 comma 3 butadiene is undergoing cycle addition with the ethylene that produces the 1 cyclohexane. Very much known familiar reaction, Diels-Alder reaction. Diels-Alder reaction. Diene is undergoing addition with the cyclization with the dienophile that produces the 6-member ring, right? But that is the thermal reaction. Now, after discussion of this PMO method on the cycle additions, you need to tell me what is the Diels-Alder reaction actually, because Diels-Alder reaction is conducted under thermal condition. Now, where it is allowed under thermal condition, that becomes the Diels-Alder reaction, right? Now, first one, 5 4 plus 5. Actually, I have given here. Don't worry. Okay, 5 4 5 4s plus 5 2 s cycle addition. In that first 4 5 system, that is 1 comma 3 butadiene is involving addition with the ethylene. Now, this is the base set or the 1 comma 3 butadiene with 0 nodes. That is, in our language, that is the ground state lowest energy molecular orbital psi 1. It is the ground state lowest energy molecular orbital 5. Both are undergoing addition that leads to the formation of 6-member reaction, 6-member product, a cyclic product. Now it is involving a cyclic array of 6-member transition state. In this transition state, the interactions are created from this end and this end, the first interaction, and this end and this end between the second end for the second interaction. In these interactions, look into here. Here shading is missing, right? Now you look into here. This is the first interaction. Is there any lobes? Sorry, any nodes?
No.
The interaction between these two lobes, there is no node.
Node.
Here the new interaction is generated between these two. Here also there is no node. 0 nodes. 0 are even number of nodes. Then it is involving 6 5 electrons or 4 and 5 plus 2 electrons. Then the transition state is Huckel transition state, and the aromaticity based on the number of electrons, 6 electrons are there, therefore Huckel aromatic transition state. When it becomes the aromatic transition state, that reaction is allowed under thermal condition, forbidden under photochemical condition. 5 4s plus 5 2s cycle addition proceeds through the formation of Huckel aromatic transition state. Therefore, the reaction is allowed under thermal condition and forbidden under photochemical condition.
సార్ ఒకసారి కొంచెం
Yes,
పైకి
yes,
స్క్రోల్.
yes, yes.
ఓకే సార్.
Okay. Next, second stereochemical mode, supra and antra. 5,4s with respect to 5,4 system, 4 electron system, supra. With respect to 2 electron system, antra. Now this is the transition state is involved. This is the base state for the 4 electron system. This is the 2 5 electrons involved base state for the 5 system. Now this is the interaction we are maintaining standard. The second interaction, the interaction is due to attraction forces are overlapping of these two lobes. For this overlapping, this CC bond undergoing rotation. Right. Then due to that reason, at the center, the stereochemistry becomes changed. Now it leads to the one node. An odd number of nodes are generated. Then the transition state is involving one or odd number of nodes and involving 6 pi electrons or 4 and 5 plus 2 electrons. Therefore, the transition state is Mobius anti-aromatic transition state. Once it becomes Mobius anti-aromatic transition state, photochemically allowed, the reaction is photochemically allowed and thermally forbidden.
సార్ ఇది 4 ఎలక్ట్రాన్స్ ది సై తో ఇండికేట్ చేస్తారా సార్? ఇది Psi1 BMO అని రాశారు కదా బాండింగ్ మాలిక్యులర్ ఆర్గాన్. 4 ఎలక్ట్రాన్స్ పక్కన
Psi1 BMO అంటే least energy bonding molecular orbital.
ఓకే ఓకే, మనం లీస్ట్ తీసుకుంటాం కాబట్టి
theory itself says that. What theory says? PMO says whatever the reactant involved in the reaction, that should be least energy. Where it is existing in least energy? The base set. Psi1 is the base set. That molecular orbital is treated for the reaction. To study the transition state. Okay, right. Over this one?
ఒక నిమిషం సార్.
Okay. Here the first pi system with respect to first pi system, the both lobes are same side. Due to that reason, this is supra. You need to write in the, I forgot to write here, supra. And
This is
with respect to second pi system is antra. That you need to write whenever you are analyzing.
opposite.
In the examination also they are looking for that. Is that clearly you are observed or not, you are understanding it or not, they are testing. Right? With respect to the second pi system, you need to write that this is antra, this is supra.
Supra.
Next, third one. This is also antra supra. With respect to the pi 4 system, it is antra. With respect to second pi 2 pi system, that is supra. Now the interaction, the first one there is no node, but the second one it leads to the one node or odd number of nodes. Okay, with respect to the first pi system, this is antra and this is supra. Now that what is the transition state? Mobius anti-aromatic transition state. Once it becomes anti-aromatic transition state, the reaction is photochemically allowed and thermally forbidden reaction.
Forbidden. Okay, sir.
Right. Next, fourth is antra. Therefore, that means the two lobes in each pi system are involving in interactions are opposite phases. With respect to the first pi system, that is the pi 4 system, this is antra. That means this in the first interaction it is involving this lobe, and then in the second interaction it is involving in this lobe. And with respect to the second pi system, the first interaction involving lobe is this one, and the second lobe is this one. Therefore, antra both are both the cases interacting lobes are opposite phases. Now it leads to the zero or even number of nodes. There is no node generation here. Therefore, it belongs to zero or even number of nodes with 6 pi electrons or 4 and 5 plus 2 electrons involved transition state. Now the transition state becomes Huckel aromatic transition state. Here you need to understand that in the pi 4s plus pi 2s, in the pi 4a plus pi 2a, both reactions are Diels-Alder reactions. Diels-Alder reactions. But in the first case, when you see this, wherever I have indicated the Diels-Alder reaction, here both all are supramode of interactions. For supramode of interaction, there is no need of bond rotations. But in the case of antra mode of rotation, here two antra mode of rotations are there. Because for interaction, here the CC bond rotation is required. CC bond rotation is required. After reaction at these two centers, stereochemistry becomes changed. For rotation, the extra energy is needed. The extra energy is needed. Therefore, this phi 4a plus phi 2a is the higher energy reaction when we compare to the phi 2s, phi 4s, and phi 2s reaction. Therefore, more commonly Diels-Alder reaction is supra mode of addition, not the antra mode of addition. Because energetically it requires higher energy and it is undergoing a geometrical change. Geometrical change means it is undergoing the CC bond rotation that leads to the change in the stereochemistry. Okay, due to that reason, most of the cases, uh, 5 4 plus 5 2 antra mode of reaction is geometrically and energetically both ways forbidden. However, it is the thermally allowed and photochemically forbidden. Okay, that thing you need to remember that. But theoretically, Diels Alder reaction is 5 4s plus 5 2s and 5 4a plus 5 2a. Understand?
Okay, sir.
You can copy it.
Okay, sir.
Okay.
Okay, sir.
Okay. Next, this is the summarized results. These are the summarized results. We call it as selection rules for the cycloaddition reactions. Cycloaddition reactions as similar to these electrocyclic reactions by PMO. Now, the type of cycloaddition, M plus N, that is 2 plus 2 cycloaddition, that is 4 n electrons in one cycloaddition. It is undergoing the supra and andra, sorry, supra and supra, andra and andra. Both are giving the same results. We have already seen. Okay, both are involving zero or even number of nodes that directed to the transition state is
Focal angle.
Huckel anti-aromatic transition state. Then once it becomes anti-aromatic, that is the thermal photochemically allowed and thermally forbidden. If the 4 and 5 electrons are 2 plus 2 cycloaddition reaction is involving supra-andra and andra-supra mode of stereochemistry, then it is involving one or odd number of nodes. When it becomes one or odd number of nodes, that becomes the Mobius, and number of electrons are 4 and electrons are 4 electrons. Therefore, Mobius aromatic transition state. Then it becomes it is
Thermal.
allowed under thermal condition, forbidden under photochemical condition. Next, 4 and 5 plus 2 electrons, supra, supra, and antra, antra, both are involving zero or even number of nodes. That is the Huckel aromatic transition state. Therefore, it is allowed at thermal condition and forbidden at photochemical condition. Next, second part, 4 and 5 electrons, 4 and 5 plus 2 electrons are 4 5 plus 2 5 cycle addition reaction is involving supra andra andra supra mode of addition. Therefore, it is involving one or odd number of nodes, that is Mobius anti-aromatic transition state. Therefore, photochemically allowed and thermally forbidden. This is the summarized selection rules for the cycle additions by the PMO method. Cycle additions and cycloreversion, both the cases, the rules are observed. you want, you can copy, or otherwise I will move.
ఒక నిమిషం. Okay, sir.
Right. Now coming to sigmatropic rearrangements. Apply the PMO method to sigmatropic reactions. We call it as analysis of sigmatropic reactions by PMO methods. Generally, we express the sigmatropic reactions IJ shift of a chiral group or atom. That is, we are classified based on the migrating group. If it is a chiral group, the group or atom is a chiral, then IJ shift of a chiral group or atom. For example, 1,3 sigmatropic shift of hydrogen. This 1,3, 1 plus 3, how much? That is the 4. Therefore, the sigmatropic reaction is involving 4 electrons. That is comes under 4 and 5 electrons or 4 5 electrons sigmatropic reaction. Now it is showing two kinds of stereochemical modes. One is the sigmatropic suprafacial shift and sigmatropic anterofacial shift. Or we call it as 1,3 suprafacial shift of hydrogen, or 1,3 suprafacial sigmatropic shift of hydrogen. This is the example. Here, this is the group which is undergoing the migration. Now, this group at migration origin. This is at migration origin. Whenever it is moving to migration termini, this is the migration terminus. Between them, if there is a transition is generated, the transition state is like this. If it is involving 0 or even number of nodes, here, especially in the case of superficial sigmatropic shift, this is the involvement of migration. The hydrogen group is involving 0 or even number of nodes with 4 electrons or 4 electrons. Therefore, Huckel anti-aromatic transition state. In both the cases, it is suprafacial. Here, whenever you are deciding that it is the suprafacial or anterofacial, no need to consider this migrating group. No need to consider this migrating group. Just you need to consider this phi system only. At the phi system, in the file system at the migration origin, that means here, at the migration terminal, here, at the both the sides, the interaction involving lobes are on same side, that is suprafacial, in the opposite side, that is anterofacial. Okay, 1 comma 3 suprafacial shift of G, that is a group or atom, proceeds through the formation of Huckel anti-aromatic transition state. Hence, the reaction is allowed under photochemical condition and forbidden under thermal condition. Okay, this is the 1 comma 3 suprafacial sigmatropic shift of hydrogen. It is allowed under photochemical condition and forbidden under thermal condition.
సార్ ఒకసారి పైకి పెడతారా సార్? Okay, sir.
Next, anterofacial mode of shifting. Look at here, very beautiful color picture is given here. This is the phi system. This is the migrating group. It is in the transition state. This migrating group is partially interacting with the migration origin. Now this migrating group is migrated to the anterofacial mode. That means in the migration origin, it is existing in the below the plane, or it is attached with the positive phase. Once it is detached, it is migrated to the It is migration terminus to the above the plane. Previously, it is in the below the plane. It is moving to above the plane. Now there is the interactions are established between the above lobe of the pi system and the migration terminus and a group that leads to one node. That one node or odd number of nodes indicates Mobius transition state involving 4 and 5 electrons or 4 pi electrons. Therefore, Mobius aromatic transition state. This one is the Mobius aromatic transition state. Then it is thermally allowed and photochemically forbidden.
Okay, sir.
Next, 1 comma 5 sheet of hydrogen, or one. It is involving two modes of migration. One is the suprafacial migration and anterofacial migration. Is clearly given. The shift of hydrogen from this migration origin to this is the position migration origin from here to